Why do engineers always measure voltage relative to ground? And why does the same circuit produce meaningless voltage readings if no reference point is defined? In this video, we'll learn what ground really means, why voltage is always relative, and how reference concepts form the foundation of every electrical and RF system. Ground is one of the most important concepts in electrical engineering, yet it is often misunderstood by beginners. Many people assume that ground is a physical destination where electricity disappears. In reality, ground is primarily a reference point used to define voltage levels within a circuit. Voltage is not an absolute quantity. It always represents the electrical potential difference between 2 points. Because of this, engineers need a common point of comparison when analyzing circuits. Ground provides that common reference and is usually assigned a value of 0 volts. There are several forms of ground used in engineering systems. Signal ground is used as a reference for electronic signals, power ground is used for power distribution circuits, and earth ground is often used for safety. Although their purposes differ, they all serve as reference points for voltage measurements. When a circuit operates, electrons move because of differences in electrical potential. However, the circuit itself does not contain a naturally defined zero voltage point. Engineers create this reference by selecting a specific node and calling it ground. Once a ground node is established, every other voltage in the circuit can be measured relative to that point. For example, if one node is measured at plus 5 volts, it means that node is 5 volts higher than the chosen ground reference. This approach greatly simplifies circuit analysis. Instead of comparing every node to every other node, engineers only need to compare each node to ground. As circuits become more complex, this reference system becomes essential for understanding voltage relationships and predicting circuit behavior. A useful analogy for ground is sea level in geography. Sea level is not a physical object that controls mountains or valleys, but it serves as a reference point for measuring altitude. When we say a mountain is 1,000 meters high, we mean 1,000 meters above sea level. Ground serves the same purpose in electrical engineering. A node at plus 12 volts is not absolutely 12 volts. It is 12 volts higher than the chosen ground reference. Without the reference point, the number itself has little meaning. Another analogy is measuring height inside a building. To know whether someone is on the 2nd floor or the 10th floor, you first need to define where the ground floor is. Ground provides that starting point for all voltage measurements. In practical electronics, ground is used as the reference node for nearly every voltage measurement. Oscilloscopes, multimeters, power supplies, and circuit simulators all rely on a common reference point to ensure consistent measurements. In printed circuit boards, engineers often create large ground planes. These ground planes provide stable voltage references, reduce electrical noise, and improve signal integrity. This becomes especially important in RF and high-speed digital systems. Ground is also critical for safety. In power systems, protective earth ground provides a safe path for fault currents. If a dangerous fault occurs, the grounding system helps prevent equipment damage and reduces the risk of electric shock to users. Every time you use a multimeter, you are applying the concept of ground and reference measurement. One probe is connected to a reference point, while the other probe measures voltage relative to that reference. Without a defined reference, the measurement would not provide useful information. Inside smartphones, laptops, routers, and communication devices, engineers carefully design grounding systems to ensure reliable operation. Stable ground references help electronic circuits process signals accurately and reduce unwanted interference. In RF engineering, grounding becomes even more important. Poor grounding can introduce noise, distort signals, and reduce overall system performance. This is why grounding is treated as a major design consideration rather than a simple wiring detail. So today, we learned that ground is not a destination for electricity, but a reference point used to define and measure voltage. Understanding ground helps engineers analyze circuits, make accurate measurements, and design reliable electronic systems. In the next video, we'll explore real battery behavior and learn why real batteries are very different from the ideal voltage sources shown in basic circuit diagrams. If you found this useful, like the video, subscribe, and follow for the next lesson.